So we have a new topic, something called cursors. We have a new topic, something called cursors, and it is very important for the basis of on the basis of interview also. So I'll repeat. We have a new topic, something called cursors. Cursors. So cursor says when an PLSQL statement is processed, Oracle creates a memory area. I'll repeat. When when an PLSQL statement is processed, Oracle creates a memory area known as the context area. Known as the context area. I'll repeat again. So I'll repeat again. When an PLSQL statement is processed, Oracle creates a memory area known as the context area for processing an SQL statement. For processing an SQL statement. For example, consider I have a table here. I have a table. I'll create, I'll place something here. Something here. As I have some space on this table, I have created, I have placed many objects here. I have placed many objects. I'll repeat. I had an empty table. I had an empty table. And wherever I find a space, I'll try to fit either any one of the item. So if I'm having space, I'll fit some item. So wherever I find any space, I'll try to fit it. So similarly, when an SQL statement is processed, the Oracle creates a memory area known as the context area, which means, for example, Rohit, number data type, size 4, 2468. And then I'll use this DBMS. I'll use this DBMS. So also print Rohit. So this is the SQL statement which is processed. This is the SQL statement which is processed. So Oracle creates a memory area. So this is the value that has been assigned to the variable name called Rohit. So now Oracle will store this value 2468 into some, it will store the value into the database. And if I want to call that, which means if I want to print that, I have to use this Rohit again. We know this earlier. When an PLSQL statement is processed, Oracle creates a memory area. So this is the value that has been processed with the PLSQL statement, and the compiler will store some value for this one. It will store this value into the compiler, and that is known as context here. Now this is the thing. This is the table. Now I have created something like Rohit. I have given the variable name Rohit, number data type, some size 4, and the value is 2468. And now this 2468 will be stored somewhere in this database. This 2468 will be stored somewhere in the database. And if I want to retrieve this one again, if I want to retrieve this again, I have to use the cursor. I'll repeat. Known as the context area for processing an PLSQL statement, which contains all the information needed for processing the SQL statement. So it's very simple. If I want to tell some generally, if I want to tell I have a table. I have a table now. Whatever the things that is possible, I'll do one thing. 1, 2, 3, 4, 5. Uppercase A, B, C, D, E. And lowercase A, B, C, B, and E. So I have placed many different values in this database, and now I want lowercase c, or I want lowercase e. So now what I do, this is the cursor, this is the cursor. It will go to the database and it will search for the lowercase e. Not this, not this, not this. It will search for the lowercase e. Yes, this is the lowercase e. It will be getting us an. So cursor, the pointer, this pointer itself, you can see this one. This pointer itself will get us the information of whatever we are required. So that is a pointer. A cursor is a pointer to this context area. Whatever the information we need to store, all those information can be stored in the database. And from those database, we will retrieve whatever the data we require. And if I want to give one more example, consider you are in the library. You are in the library, you will be having a rack like this. So here, some different books. You will be having some different books in each and every cell. And if you want the particular book, you will be searching for any particular book. So what you will do, you will search. Anyways, the textbook name will be written behind the book itself. So you'll be searching. For example, you want your academic subject, mathematics, some mathematics subject. So you will search mathematics 1, not this, not this, not this, somewhere. This is the mathematics book. So you are pointing to this particular book from these context area. You have many books. But you are searching for one particular book, that is mathematics. So you will search that one itself. And if you want to search, if you want to take some other physics book, and you will search here, it will be somewhere over here. So you will search for the physics book. That means cursor is at the moment, it is a pointer. It is a pointer to the context area. So cursor is a pointer to this context area. Pl-Sql controls the context area through the cursor. So this area is covered, this area is controlled with this cursor. So this is the cursor. See, as of now, I'm using this pen. And wherever I mark, it will be marked. Because this is the page. This is the entire page I'm having. This is the entire page I'm having. And I can mark wherever I want. I can mark wherever I want. So Pl-Sql controls the context area through a cursor. A cursor holds the rows. It holds the rows. Rows are nothing but either one row or more rows. So the cursor holds rows, one or more, returned by a SQL statement. I'll repeat. A cursor holds the rows, one or more, returned by a SQL statement, which means a cursor contains information on a select clause and the rows of the data accessed by the cursor set. I'll repeat this line. A cursor holds the rows. A cursor holds the rows, which means, for example, select ename from a job from EMP. Ename from a job from EMP. So you will get the output as all the ename and all the job. So you'll be getting some Smith working as some salesman. So you got the row, you got the rows, either one or more. So you got two rows here, either one or two. So that's what a cursor holds the rows, which means either one row or more rows, returned by a SQL statement. See, this is a SQL statement we have written, and that will get us the output. See, we have many column names and we are selecting ename. So the compiler will jump to the ename column and it will get us the ename column. And then again job. We'll jump to the job column and it will get us all the job column. So a cursor holds the rows, which means the pointer from whichever the table, whatever we want, we have to point it. We have to specify that using the cursor. We have to specify. So the cursor goes to the compiler. These are the things user is asking. You give me, I'll get back. So a cursor holds the rows, one or more, returned by a SQL statement. Returned by a SQL statement. So we have to write the code. what needs to be selected, which means a cursor contains information. See, this is a cursor. So this is a cursor. Select. I'm pointing to the import table. I am pointing to the import table. So it contains the information on a select statement. So it has information on a select statement, select ename, comma job, and the rows of the data accessed by cursor set. So whatever the information I am trying to retrieve, the same row, the same information will be given as an output in the form of rows. So that is called as cursor. It's very simple. A cursor is a pointer to the context area. See, I'm having these many words. I'm having some hundreds of words here, hundreds of words. Now, I just want to point towards process. I have some hundreds of words here. I have hundreds of words, but I want to point to the process. So I have process here. So this is a pointer. I'm pointing to this context area using cursor. Is it clear so far? Abhishek, clear? Nitya, Sai, Shiva, Sonia, Yamini. I'm audible?
Yes, sir.
Yes, sir.
So a cursor is used to refer to a program to fetch and process the rows returned by a SQL statement once at a time. See, cursor is nothing but it is used to point, it is used to get some information. It is used to get some information by pointing to the particular information. We will be having different tables, different information, but from those all the different data, I want to select the particular one. So I want to point. We want to point to one particular data. So to get that, we have to write the sequence. We have to write the sequence statement, like SQL statement. Select so on so so on so from this table that table. So whatever the information we specify in this select clause, and whatever the particular table we are going to specify, it might be employee table, department table, or customers table, student table, bonus, whatever the table it might be, the compiler will get the cursor will go to the compiler, and the compiler will give the response to the cursor, and cursor will get as the output. So a cursor is used to refer to be a program to fetch and process. To fetch and process. To fetch employee name, job, salary, commission, department number, whatever the information we want to fetch, that can be fetched, and the rows return, which means the output, whatever the information we are trying to select, all those information will be given in the form of a rows returned by a SQL statement. So all those things have to be specified or written in the terms of SQL statement. Once at a time. At a time, we can get any information, any number of information, and we can get those information in two ways. So cursor is a pointer to the context area to get some information using the SQL statements. And then we can get those information from any table in two ways. The one is something called, or we can also call it as the types of cursors. You might be asked some questions based on this one. Types of cursors. What is implicit cursor? What is explicit cursor? Example for implicit. Example for this one explicit. Difference between these two. Advantages, disadvantages. So they might ask any question based on this one. So we have two types of cursors. The one is implicit cursor, and the second one is explicit cursor. Implicit cursors and explicit cursors. So implicit cursor says implicit cursors are automatically created by Oracle. Implicit, internally stored information, existing information, already created information. I repeat, implicit cursors are automatically created by Oracle. Automatically created by Oracle whenever an SQL statement is executed. So I repeat, implicit cursors are automatically created by Oracle whenever an SQL statement is executed, which means when there is no explicit cursor for the statement, programmers cannot control the implicit cursors and the information in it. I'll repeat again. This line says when there is no explicit cursor from the first, implicit cursors are automatically created. So, for example, we have seen employee table. From this employee table, we had a couple of columns like employee number, EMPV, employee name, job, salary, MGR, hire date, commission, and then department number. So these are the different columns we had. These are automatically created. These are automatically created by Oracle. So whenever we want to do something, whenever we want to retrieve any information using implicit cursor, there should be already existing information. So implicit cursor is nothing but the information is already stored. And whatever the information that are already stored, we have to get the information from those stored information. That is called as implicit, which means when there is no explicit cursor for the statement, which means I have something like, so I'll ask the compiler, I want to select phone number. I want to select phone number from EMP table. So this is not, this phone number is not a implicit value. It is not an implicit data. It is not there in the database. So it is an explicit, which means first we have to save it. It is not there in the database. Phone number is a column which is not there in this employee table. So that is explicit data, which means it is not there in the database. So when there is no explicit cursor, so see, I don't have phone number column in this I don't have this phone number column in this employee table. When there is no explicit cursor for the statement, programmers cannot control the implicit cursors. See, now I want phone number. I cannot do nothing now. I'm trying to get the information from the employee table, but I don't have the information. I cannot do nothing. I just have to sit silent. So when programmers cannot control the implicit cursor and the information in it, I cannot do nothing. If it is implicit, if it is already existing, I can retrieve that. For example, if I go with the salary, yes, I can retrieve. If I go with the MGR, reporting manager, yes, still I can get that. If I go with the Gmail, no, I cannot do nothing. Because Gmail is a column name which is not there in the database. Because Gmail acts like a explicit, externally saved external information. Which is, if it is implicit information, that is already stored in the database. If it is implicit, the information should be already there in the database, and from those information we need to retrieve already existing information. And if it is explicit, we cannot do nothing. If it is we cannot do nothing if there is no data in this implicit cursor. That means implicit data. I'll repeat. If there is no data in this table, I cannot control. See, if I want to return Gmail column from employee table, no, it is not possible. Phone number, not possible. Aadhaar card, PAN card, no, not possible. Salary, possible. Employee number, possible. So whatever the existing columns that are there in this table, based on those columns, I can do anything. I can do anything so that I can return whatever the information I require. But if I try to require the information which is not there in this database, the programmer cannot control. Programmers cannot control the implicit cursors and the information in it. So these implicit cursors are created by default. Implicit cursors are created by default, which means automatically created. That's what we have read in the first line. Implicit cursors are automatically created, or these implicit cursors are created by default to process the SQL statements when DML statements are executed. So using these cursors, you can process the DML statements. But our DML statements like insert, update, and delete. So insert, update, and delete. So we can perform this DML statements using implicit cursors. So for insert operation, the cursor holds the data that needs to be inserted. If I want to insert any information, using the cursor. So that insert operation, the cursor holds the data that needs to be inserted. If I want to insert, the cursor hold some data, whatever the data it has to be inserted. So that data will be held by the cursor. If I want to delete or update, in case for update and delete operations, the cursor identifies the rows that would be affected. Say I'll repeat. If it is insert, the cursor holds the data that needs to be inserted. If it is for update and delete operations, if I want to update or if I want to delete any records, the cursor identifies the rows that would be affected. The rows that would be affected, which means, for example, I'll do one thing, select. So I want to delete some record. I want to delete some record. So delete where so also conditional, right? If I want to delete or if I want to update, either delete or update. If I delete any record, so the cursor identifies that one record is deleted. We have seen this one. If I insert any record, one row inserted. If I insert any one record, it says one row inserted. It says one row inserted. If I delete any record, one row update. So if I delete or update any record, this that says one row deleted or one row updated. So similarly, if I delete or update any record, the cursor identifies the rows. The cursor identifies the rows that would be affected. So affected is nothing but how many rows have been deleted. If I delete one row, it says one row deleted. If I delete two rows, it says two rows deleted. Same thing with update. If I update any record, it says one record updated. If I record multiple records, that says these many records are updated. So that will be identified by the cursor if it is for update and delete. We'll see one example a little later. So in Pl-Sql, you can refer to the most recent implicit cursors as the SQL cursor. So in Pl-Sql, you can refer to the most recent used or recent implicit cursors such as percentile found or attribute found. Attribute found is open, not found, or row count. So these are the recently used implicit cursors. Implicit, I'll repeat. In Pl-Sql, you can refer to the most recent implicit cursors such as attribute found or percentile found, attribute is open, not found, and row count. Row count. For example, when you execute the SQL, that means which is DML statement, when we execute the DML statements like insert, update, or delete, then the cursor attribute tell whether any rows are affected and how many rows have been affected. See, I'll repeat again. When we execute DML statement, like if I insert or if I update or delete any records, so the cursor attribute, which means these cursor attribute says whether any rows are affected and how many rows have been affected, which means if I delete and the cursor says these many records are deleted, if I update, these many records are updated, if I insert, these many records are inserted, so that all those information can be gathered or retrieved with the help of the row attribute, which means this one, this SQL attribute. These are the attributes which is used to help to get some information. How many rows are inserted, updated, deleted. So all those can be retrieved with the help of these cursor attributes. So the following type provides the description of the most used attributes, and any SQL cursor attribute will be accessed as SQL attribute name as shown in the below. I repeat, the following types provide the description of the most used attribute. So these are the most used attributes. And we have the next example, how these attributes are used. How these attributes are used, and any SQL cursor attribute will be accessed. So any SQL cursor attribute will be accessed as SQL percentile attribute name. SQL percentile attribute name as shown below. We'll see what is SQL percentile attribute name. So the first one, found, attribute found. So this says it returns true. Attribute found says it returns true if an insert, update, or delete statement affected one or more rows. I repeat, found, attribute found. It returns true. It returns true if an insert, update, or delete statement affected one or more rows. For example, I will insert or I will update or delete any records from ename, salary, and job. I will insert one record here, and another record here. Or I will update the records from these three columns, or I will delete the records from these three columns. Now, after deleting that, the compiler says, so cursor attribute says, 3 rows have been deleted, or 3 rows have been inserted, or 3 rows have been updated. If it is updated, so that's how we will get the output. We'll see one example a little later. So found, which means if it is affected, that means if it is changed, if the records are inserted properly, or if the records are updated, or if it is deleted properly. So this one says, yes, I have found that. The compiler says, I have found that 3 records have been inserted, 3 records have been updated, or 3 records have been deleted. Found. The second one, not found. So this is logical opposite to found. Logical opposite to found. See, it returns true if an insert, update, or delete statement affected no rows. If I'm trying to insert any record, or trying to update any record, or trying to delete any record, if it doesn't update, insert, or delete, then the compiler says, no, no records have been updated, no records have been deleted, no records have been inserted. Say I repeat, not found, not found. So the logical opposite says that, for example, see, I have a table, or this is a room. This is some room. And I'll ask you to search for a, I will ask you to search for a square. So I'll ask any one of you to go to my house, and I'll ask you to search whether do you find any square. If you find it, you will say found. I found square. If you find it, you will say, for example, let me tell you. Yes. So if you found the square, you will tell, yes, I have found the square. And I'll ask you again, find the star. Go to my house, and search the star. And you'll go to my home, and you'll search. This is not the star, not the star, not the star. And you'll tell, not found. Not found. Not found. So similarly, not found. It is the logical opposite of found. It returns true. Logical not operator returns true if an insert, update, or delete statement affected no rows, which means if I'm trying to insert any record, update any record, or delete any record, but still none of the records are updated, deleted, or inserted. Then the compiler says no rows selected, no output, sorry, no inserted, no rows updated, no rows deleted. So it will be found with the help of not found attribute. Then something called is open. Is open always returns false when implicit cursors, because, I repeat, is open, attribute is open, always returns false for implicit cursors, because Oracle closes the door, sorry, Oracle closes the SQL cursor automatically after executing its associate associated SQL statement. I repeat again, is open. Is open always returns false for implicit cursor. For example, I have employee table. So I have employee table, and from these employee table, I have a couple of columns like employee name, e-name, job, salary, commission, MGR. So let it be. So on. So these are the columns from implicit cursor. And now it says is open. So before that, what I'll do, I'll ask the compiler to give me the salary. Select salary from EMP for the first time. I'll ask the compiler, give me the salary from EMP. So what happens? Compiler will give the salary. It will give the salary column. And next, again, I'll go with select commission. Select commission from EMP. So the compiler doesn't give the output. It will not give the output because first time I have asked for the salary column and it has given the output. It will give the output salary column. And if I try to execute this second time, I'll try to execute some other column second time, but the compiler doesn't give any output because it always returns false, which means for the second time, it always returns false because Oracle closes the SQL cursor automatically once after executing its associated SQL statement. Once any statement is executed, Oracle closes the door. So Oracle closes the cursor. It's like, for example, the same house. So this is my house. And some randomly a delivery boy comes from Zomato. From Zomato, randomly some delivery boy comes. Or I'll order some three items. Item 1, item 2, and item 3. So first boy comes. First Zomato boy comes, and he will deliver the order. He will deliver the. I'll take it. So I'll take it. Then I'll close the door. I will close the door because he doesn't have the second. He doesn't have the second item. He just have the first one. So he just gave me, and I took it. And after that, I'll close the door. I'll close the door, and second time, some other boy comes. He has to knock the door. Second boy has to knock the door so that I'll open the door and I'll again collect the second order. And I'll not wait until the third boy comes in the door. I'll not be standing at the door waiting for the third boy. I'll again close. I'll again close my door. And until the third boy comes and knocks the door, I'll be closing the door. So the third boy comes and he will knock. He will knock the door. So again, I'll open. Again, I'll open. Then I'll collect the record. I'll collect the order. Again, I'll close the door. So similarly, here, once I try to execute any output, or once I try to execute any SQL statement, the Oracle cursor automatically closes its door. So again, second time, we have to ask the compiler, open. Open, that's what we have to use, is open. So if I use this attribute, for the next query, the compiler will open and it will give us the output for the second query. Again, third time, is open, next query, fourth time. Whatever the number of times we are trying to return the data, and the same number of times we have to use that attribute is open. So that always it will be open, and whatever the information we require, that can be retrieved. So that is called as is open. So is open always returns false for the implicit cursor because Oracle closes the SQL cursor automatically after executing its associated SQL statement. And then row count attribute row count. It returns the number of rows affected by an insert, update, or delete statement. So I'll repeat this one. Row count. Row count says it returns the number of rows. It returns the number of rows affected by an insert, update, or delete. If I'm inserting 3 records, the row count says 3. What are the records that are inserted? 3. If I update 4 records, and the compiler says 4. 4 records are updated. It will give the count. It will give the number of rows that are inserted, the number of rows that are updated, or the number of rows that are deleted. whatever the number of rows deleted, updated, or inserted, it will count and it will give us the output. These are the number of rows inserted, number of rows updated, and the number of rows deleted. So row count returns the number of rows affected by an insert, update, or delete. Is it clear so far?